So today we are going to solve the Newton's law of cooling problem with an example of heating and cooling of a building. Let's consider this example of the building where we have this blue color building, and in this building at particular time t we have temperature is equal to T, and then we want the temperature of the building to be T underscore W, which is a wanted temperature. And outside of the building we have the TA, which varies sinusoidally like this, and the equation of that sinusoidal variation can be given using this form: TA is equal to A minus C cos 2 pi by 24T. And then we have some constants where P is equal to rate of increase of temperature due to humans and machines. And then we have another two coefficients, K1 and K2, which are negative constants. So once we convert all of these, we get this particular ordinary differential equation which can describe our heating and cooling of the building. So basically we are going to solve this for the T, which will be a function of K1, K2, P, and the wanted temperature as well as the TA. So let's do it. So first of all, we have a TA which is varying sinusoidally like this. TA is equal to A minus C cos of 2 pi by 24 into T. So basically A is the vertical shift in the sinusoidal variation of the ambient temperature or outside temperature. C is, you can say, the amplitude of this particular variation here. So first of all, we can simplify our ordinary differential equation so that we can bring up all the constants together and replace those constants with some coefficients. So let's do that. So first of all, I am going to couple up K1 and K2 into T minus K1 into TA minus K2 into TW, plus we have P as a constant. So we can substitute, or we can assume that K1 plus K2 as one single constant coefficient, which we can denote by alpha. Then we can also assume that K2 into TW is equal to beta. So since TW is like constant, because we are not going to change that with respect to time, it's the wanted temperature inside the building, so we can consider that as a constant value. So now our ODE becomes like this: alpha into T minus, we can take the K1 and we can substitute the value of TA, which is this inside this equation. So K1 into the bracket, we have A minus C cos, this I can say that pi by 12 into T minus beta. Sorry, actually here we can say that so minus P plus K2 t w is equal to beta. So this complete whole term is going to be a constant. So this complete term is going to be, I just took the minus sign outside the bracket, so p will have a negative multiplication. So this is minus p plus k2 into tw is equal to beta. So I am putting or considering beta as a single coefficient for this complete term. So we can go ahead and we can take this alpha into t to the left side. So our equation now becomes delta t dt minus is equal to, so this will be positive k1 c cos of pi by 12 into t, then we have minus k1 into a and minus beta. So again we can consider this k1c and k1a with some other single coefficients or constant. So we can say that k1 into a is equal to gamma and k1 into c is equal to epsilon. So now our ordinary differential equation will be like this. Oops. Epsilon cos t minus gamma minus beta. We can solve this simplified ordinary differential equation using the integration factor. So we can consider our integration factor to be mu of t is equal to e to the power integration of p of t into dt. So in the above equation here, our p of t is equal to minus alpha and g of t is equal to epsilon cos pi by 12 t minus gamma minus beta. So we get integration factor which is mu of t is equal to minus alpha into t. So now our solution to the ordinary differential equation with the integration factor is expressed in this form, which is integration factor into t is equal to integration factor into g of t to dt plus c. So we can solve this. So we can put e to the power minus alpha t into t is equal to the power minus alpha t, and into the bracket this whole term, this gt. So it will be epsilon epsilon cos pi by 12 into t minus gamma minus beta dt plus c. So we can simplify this equation like this. So now here you can see that we can solve this particular term directly, like because this gamma plus beta is constant, so we can take that outside the integral and we can solve that directly. But for this term we can actually use the integration by parts rule, where we have, or we can consider u of t is equal to e to the power minus alpha t, u dash of t is equal to minus alpha into e to the power minus alpha t. The second term we can consider here is v of t, which is cos term, and the integration of v of t is equal to 12 by pi cos integration is sine, and then we have this term inside the bracket. Now we can put all this in our integration by parts rule formula, which gives us the integration of e to the power minus alpha t cos of pi over 12 t is equal to e to the power minus alpha t 12 divided by pi into sine of pi over 12 t minus integration of, now we have this minus sine e to the power minus alpha t, again integration of vt, which is 12 over pi sine pi over 12 into t, then plus c. So for those who don't know the integration by parts rule formula, so I'll just write it down here for you, just for your reference. So integration by parts of two functions u of t into v of t dt is given by u of t integration of v of t dt minus integration of u of t, so it should be a bracket here, into integration of v of t dt. So this is the formula for integration by parts rule. So we have used this to solve our this particular integral term. So now we have to integrate this one more time, so that on the right hand side as well we will get the integration term in terms of e to the power minus alpha t into cos pi over 12 into t. So we can do that, but let's first of all simplify this a little bit. So this should be 12 e to the power minus alpha t divided by pi. We have sine here, so this is t, then this minus and this minus will become plus. We take 12 pi and alpha outside the integral, so it will be 12 alpha divided by pi, and into the bracket we have integration of e to the power minus alpha t sine of pi by 12 into t. Oops, it should be bracket plus c. Actually we have one c here already, so just we don't get confused, I'll add a suffix here, so we can denote this one as c1, let's say, because we are saying this constant term and this constant term coming from this integration is different, not the same. So we'll get this one. So now we will integrate this again using the integration by parts rule. So we will get 12 e to the power minus alpha t divided by pi into sine of pi over 12 into t plus this is 12 alpha divided by pi. Now into the bracket we are using the same integration by parts rule, so we will have minus e to the power minus alpha t into 12 by pi cos of pi over 12 into t. So this minus sign is coming from the integration of sine, which is minus cos, so we have added that in front of e. Now minus integration of again minus alpha e to the power minus alpha t, I'll write down here, so it will be again minus sine because of the integral of sine, so this should be whole bracket into the cos of pi over 12 into t. So this minus sign is again coming because integral of sine is minus cos, so we have this complete bracket closed here. So we get another constant from this integration, which we can say that we can add that to this c1 and we can say it's now c2. So let's simplify this and we can get this particular term, same term on the right hand side as well. So at the end we get like this. So we are having this minus sign because of this minus, so it should be, and we are taking 12 by pi outside the bracket, so it will be 144 alpha divided by pi square into e to the power minus alpha t into cos of pi over 12t. Now minus because we have this minus and this minus becoming plus, but then we have again minus sign here, so that will become a minus again. So we have 3 minus, so it will be a minus 144 let's write it down actually, because I don't have space. So let's put the minus sign here. Let's put it here. Minus 144. Now we get alpha square, because we have one alpha here and one alpha here, so it will be alpha square divided by in pi square and into the I would say into the integration e to the power minus alpha t cos of pi over 12 into t plus c2. Okay, so now as you can see, we have this particular term on the right hand side of the equation, and we have the same term on the left hand side of the equation as well. So we can take this term and add it onto the left hand side of the term, so we get so we get 1 plus 144 alpha square divided by pi square integration of e to the power minus alpha t cos of pi over 12t is equal to 12 e to the power minus alpha t divided by pi and into the bracket. We are actually taking this particular term common from these two terms on the right hand side, so we get sine of pi over 12t minus so we have 12, then we have alpha, and we also have 1 pi. Yep, into cos of pi over 12 into t, bracket close, and plus c2. So we can again further simplify this, so that because at the end we want the solution for integral of e to the power minus alpha t into cos of pi over 12t, which we can substitute in our solution with the integration factor. So we can finally say that our integration of e to the power minus alpha t into cos of pi over 12t is equal to, I can simplify that on a rough book, but once you simplify that, you will get the simplified solution like this, so which will be in the form of 12 pi e to the power minus alpha t divided by 144 alpha square plus pi square. So basically we are multiplying this pi square here, which will be pi square plus 144 into alpha square divided by pi square, and we are adding or we are dividing that complete term on the both side. So on this side we'll get this, and here we will have 1 basically. So, and into the bracket we are having sine of pi over 12 into t minus 12 alpha divided by pi of cos the same factor and then c2. Okay, so now we can put this particular solution of this integral into our solution with the integration factor, which is this. So we can put that solution of our integral into this equation, and we will get e to the power minus alpha t into t is equal to, so 12 pi, we had the epsilon into the multiplication, so it will be epsilon into e to the power minus alpha t divided by 144 alpha square plus pi square into the bracket sine of pi over 12t minus 12 alpha over pi cos of pi over 12 into t, plus we had the term with the summation of gamma and beta, which was e to the power minus alpha t into gamma plus beta divided by alpha, plus I would say that now we had a c in the equation of the solution with the integration factor, but we have c2 here, so I can say that that constant term is now c3. So we can divide both side by e to the power minus alpha t, so we can just cancel those out like this, and we can add here e to the power alpha t, right? So our solution, final solution would be like this. So t is equal to 12 pi epsilon divided by 144 alpha square plus pi square, and into the bracket sine pi over 12 t minus 12 alpha divided by pi cos of pi over 12 t bracket close plus gamma plus beta divided by alpha, and then c3 into e to the power alpha t. So we have this final solution. I can just highlight that with some. So now using this equation we can actually get the temperature of the building, which will be a function of P, which was the rate of increase of temperature due to humans and machines inside the building, then K1 and K2, which were the coefficients of the negative coefficients of the equations, and then we also had a TW, which was also constant, which was wanted temperature inside the building. So we have this solution in final solution here. We can also confirm our solution using some mathematical computer algebra systems, which are, for example, Mathematica or even the Python Sage Math. So in the next video I'll show you how we can solve this using the Sage Math, and we will try to compare, or we will actually compare our this solution with the solution in the Sage Math. So till that time, I hope you like this video, and thanks for watching.